Welcome back to this set of videos on intermediate microeconomics. My name is Revi, and today we'll talk about certainty equivalence. So far we've been building the stage of uncertainty, and what we've been working on is the definition of a risk-averse individual. And what we want to do next is, I want to give you an example. Imagine that you have a lottery, the tossing of a coin, if you like. If it comes up head, which happens with 50% of the time, you get £1. And if it comes up tail, which also happens with 50% of the time, you get 0. This is a lottery one. And imagine that you're dealing with risk-averse individuals. And I might want to ask you, what's the maximum amount that a risk-averse individual would be willing to pay for this lottery? So let's think a little bit about that. Would a risk-averse individual pay £0.50 for this lottery? If you think about this, the pure definition of a risk-averse individual immediately eliminates this as an option. The answer is no. Why? Because look back at the definition of a risk-averse individual. It's not someone who dislikes risk, right? This is a risky lottery. Sometimes he'll give you some money, sometimes he won't give you some money. So there's risk, there's uncertainty there. But the expected value of this lottery is £0.5. And the definition of a risk-averse individual is that between the option of the expected value of the lottery, which is £0.50, or the lottery itself, they would prefer the expected value. So this is that classical case, or we could have reversed that. And the corollary of that is that a risk-averse individual, risk-averse will never pay the expected value of a lottery. So imagine that the lottery has a price, and you immediately know that a risk-averse individual will never pay more. It will never pay the expected value. So they would only be willing to pay something less. And that's where the main definition that I want to talk about today comes in. What is this maximum willingness to pay for a lottery? Or in other words, what is a certain sum of money that would make you indifferent between the lottery and that certain sum of money? Well, to answer that question, we need a utility function. So let's assume that the utility for money, which we're representing with x, is square root of x. Then now I can ask the question, what is the certainty equivalent of this lottery? Which is equivalent to saying, what's the maximum amount of money that this agent would be willing to pay? Well, from the first video on this uncertainty, we made the assumption that whenever we have uncertainty, we are going to look at the expected utility of lottery one. And that's going to be 50% of the time, you're going to get square root of 1. And 50% of the time, you're going to get square root of 0. And therefore, the expected utility of this lottery is going to be 0.5. This is lottery 1. Now, what I'm looking for is the utility of a certain amount of money. So the certainty equivalent is in monetary terms. In monetary terms, such that the square root of 0. Of the certainty equivalent equals to the expected utility of this lottery, which is 0.5. And therefore, square both sides, the certainty equivalent of the lottery. Okay, certainty equivalent is always of something, right? Of the lottery. In this case, is going to be 0.25. And remember, it's in monetary terms, so I can put pounds. So what does this tell me? Well, this tells me that the most that this person will be willing to pay for this lottery would be 0.25 pounds. Okay, so certainty equivalents come into play in problems with uncertainty, and I wanted to give you this perspective on what it means for a certainty equivalent. So let's summarize. Whenever you're given a utility function, you're always given a utility function for a sure outcome, right? This is utility for, if you like, sure money, sure or uncertain. Whenever you're given a lottery, you have uncertainty, and therefore you need to assume that you are an expected utility maximizer. And if you want to find the certainty equivalent of an uncertain lottery, you first have to find the expected utility of that lottery and equalize that expected utility with the utility of some sure money, which you call certainty equivalent, and rearrange to find it. I hope you find this helpful. I'll see you on the next one.